Okay, so here the algebraic equation are in the form of a combination of fractions. So let's change this. Here we do have 1 by 2x, 1 by 4y and 1 upon 3z. So for our convenience, we can assume this 1 by x as p. You can assume to a, b, c also, it's your convenient. You can assume any variable apart from x, y, z, except x, y, z. So I'm assuming 1 by x as p, 1 by y as q, 1 by z as r. Okay, the assumption is the first step. So now we are going to apply these assumptions on our question and we are going to rewrite our equation in terms of p, q and r. Okay, let's do that. So it's 1 by 2x. So 1 by 2x can be written as 1 by 2 times 1 by x, isn't it? Which is 1 by 2 into, we assumed 1 by x as p. So it will become 1 by 2 into p, which is nothing but p by 2. So I can rewrite this as p by 2. Can you follow?
Yeah.
Similarly, 1 by 4y can be written as 1 by 4 into 1 by y. I'm going to change my 1 by y as q. So 1 by 4 times q can be written as q upon 4. And we do have negative 1 by 3z, which can be written as 1 by 3 times 1 by z, which is nothing but 1 by 3 times r, because I'm rewriting the 1 by z into r. So which is r upon 3. Okay. So we can frame our equation into p by 2 plus q by 4 minus r by 3 equal to 1 by 4. So that is going to be our equation 1. Not equation 1, you just, okay, you can assume it as an equation 1. We'll move on to the next one. The next equation. 1 by x is equal to 1 upon 3y. What is 1 by x? 1 by x, we initially assume it as p, isn't it? So just replace 1 by x as p. And 1 by 3y can be written as 1 by 3 times 1 upon y. So 1 upon y, what is 1 upon y? It's q. So it's going to be 1 by 3 into q. P is equal to q upon 3. We rewrote the second equation. Can you follow this? Okay. So we are doing the same thing for the third equation also. And here you do have a constant in the form of a mixed fraction. We'll change this mixed fraction into a improper fraction. How can we do that? We have to multiply these two and then you have to add this. So it's 2 times of 15, which is 30 plus 2. So that's going to be the numerator. 32 is going to be the numerator for the improper fraction. And already you do have 15 as the denominator in the mixed fraction. So we are going to do the same for the improper fraction also. So these are all basics. You know how to convert a mixed fraction into an improper fraction, isn't it? So it's 32 upon 15. Okay. I hope these 3 steps are clear. We'll move to the next step. Okay. So now we are going to simplify this. How can we simplify it? Here, we do have 3 different denominators in the fractions. Whenever we have a different denominators in the fraction, if the fractions are in the form of addition or subtraction, we go for LCM. Okay, we do take LCM. So let's take LCM for this first. So what would be the LCM for 2, 4, 3? 1, 2, 1. Just write 3 as it is. 113. 3 divided by 3 is 1. So these are the prime factors. It's going to be 2 into 2 into 3, which is nothing but 2 2s are 4, 4 3s are 12. So 12 is going to be the LCM. Are you following it?
Yeah.
Okay. So let's apply LCM to this. The LCM is 12. Here you have 2. Give me a second, Manase. So you have P upon 2 here. So what do you have to do? Just divide this 12 by 2. You'll be having 6 as the quotient. Thus, that quotient needs to be multiplied with the P. It will become 6P. After that, Q upon 4. You have 4 in the denominator. Divide the 12 by 4. You'll be having 3 as the quotient. Multiply that quotient with the numerator. It will become 3Q. And for R, you have 3 as the denominator. If you divide 12 by 3, you'll be having 4 as the quotient. So it's 4 times of R. So it's going to be minus 4R equal to 1 upon 4. Can you follow this? Okay. So now you can simplify this. Here, 12 can be expressed as 3 into 4, isn't it? So I'm just rewriting the 12 as 3 into 4. So let's cancel the 4 in the left hand side and the right hand side. So we will be left with 6P plus 3Q minus 4R upon 3 equal to 1. Take this 3 to the right hand side. It will become multiplication with the 1. 1 into 3 is 3. So this is our new equation. So you can assume this equation as the first equation. Can you follow this?
Yeah. For this, the 12 in the denominator initially, can we just bring that directly to the other side? So it will be 12 4 and you'll get
12 by
3
4, you will
right
get 3. Yes. Either way it is correct. Both the options are correct. Yeah, we can do like that. Okay. Okay, fine. So the next equation, P is equal to Q upon 3. So here also, they are just taking this 3 to the other side. Here the 3 is in division. If you take it to the other side, it will become multiplication. So Q is nothing but 3 into P. And the next equation. What is the next equation? It's P minus Q upon 5 plus 4R equal to 32 upon 15. Do not worry about this constant. Okay, first try to solve this left hand side and then we can equate it to this constant and we can simplify this further. So let's take LCM on this because here you do have the denominator as 5 we can assume these denominators, the denominator to the P and R is 1. Yeah. So now we can go for LCM. Obviously, it's going to be 5 only. 1 into 5 into 1, it's going to be 5. So it's 5. So P will become 5P and Q will be Q only. 5 divided by 5 is 1. So 1 into Q is going to be Q. And what about this 4R? 5 divided by 1 is 5. If you multiply the quotient with 4R, it's going to be 20R is equal to 32 upon 15. So let's rewrite this 15 in terms of 5. We can write this as 3 into 5. 3 into 5. So now you can cancel this 5 and this 5. Yeah. So now you do have 32 upon 3 on your right hand side. In the left hand side, you do have 5P minus Q plus 20R. So let's simplify this. You take this to the other side and multiply. So it's going to be 3 times of 5P minus Q plus 20R equal to 32. So far clear?
Yeah.
All right. So it will become 15P minus 3Q plus 60R is equal to 32. So that is going to be our equation 3. Shall I clear the screen?
Yeah.
Okay. So we do have all these 3 equations now. Let's use elimination method for solving this, for finding the value of P, Q and R. So how can we simplify this? So the equation 2 looks very simple because we do have only 2 variables here, P and Q. There is no R. Okay. So we can rewrite P in terms of Q or else Q in terms of P. So what they are doing, they are just substituting this equation 2 in the equation 1. So they are changing the 3P as Q. How can we do that? You have 6P plus 3Q minus 4R equal to 3 here. 6P can be written as 2 times of 3P. Write the remaining as it is 3Q, 4R equal to 3. So we can rewrite 3P as Q. We are substituting it. Again, you write the remaining thing as it is. 2Q plus 3Q. Now you can simplify this. You can add the similar variable. It's 5Q minus 4R equal to 3. So it's 5Q minus 4R equal to 3. Is it clear?
Yeah.
Okay. So let's assume this is the equation 4. Similarly, we can substitute the equation 2 in equation 3. If you do that, so you do have 15P minus 3Q plus 60R equal to 32. Again, 15 can be written as 5 into 3P minus 3Q plus 60R equal to 32. So 5 into what is 3P? 3P is Q. So just replace 3P as Q. It became 5Q minus 3Q plus 60R equal to 32. 5Q minus 3Q is nothing but 2Q plus 60R equal to 32. So now we have deduced the equation with the 3 variable into a equation with a 2 variable. So this is going to be our equation 5. So if you look at the equation 4 and 5, both the equations are having the variable Q and R with it. Can you follow?
Yeah.
Okay.
In the textbook, it's actually a bit different.
In the textbook, they solved for P. Anything is fine. What they did, they just substituted P as Q by 3.
Okay.
Anything is fine. You can either change the P into Q or Q into P. Anything is fine. It's just the relation between P and Q. Anything is fine. You can solve it like this, or else you can solve it like this also. But the thing is, make sure you do have the same substitution on both the equations. Like in the first equation also, I've replaced 3P as Q. In the third equation also, I did the same replacement. I replaced 3P as Q. Okay? Yeah. Okay, please note it down. We'll solve the 4 and 5.
Wait, is it possible to reduce 5 maybe?
Is it possible to reduce the fifth
5
equation by dividing it by 2?
Yeah.
Yeah, we can do that. It's a good idea. So Q plus 30R equal to 16. Very good. So we can assume this as the equation 5. Thank you.
Yeah, I took it down.
Okay. Just a second. Let's solve the equation 4 and 5. We'll try to find the value of Q or else R. So fourth equation is 5Q minus 4R equal to 3. The fifth equation is Q plus 30R equal to 16. So how can we change this? How can we simplify this? Here you do have Q. Here you do have 5Q. If I multiply my fifth equation by 5, I would be able to achieve the same 5Q. So I'm going to multiply the entire fifth equation by the value 5. So just multiply this equation by 5. What will happen? It will become 5Q plus 5 into 30R will become 150R is equal to 5 times of 16 is 80. So now this is our new fifth equation. Let me write the fourth equation again here. It's 5Q minus 4R equal to 3. How can we solve this? Change the sign. Change the sign. Now we can cancel out the 5Q with the 5Q. 150R plus 4R will become 154R equal to 80 and negative 3. It's going to be 77. So it's 154R equal to 77. I can write R as 77 upon 154. So 77 times 2 is 154. So you can cancel it out. R is nothing but 1 by 2. Is it clear?
Yeah.
Okay, please note it down. See, we are getting the same value.
I'm done.
Okay. Okay, I'll figure this. And look at the third equation. (15p minus 3q plus 60r equal to 32. You can substitute in the equation 1 or equation 3. Anything is your convenience. Okay. So
can we substitute it in equation 5? Q
equation 5. Yes, we can do that. We can do that. Yeah, we can do that. Like this, I think this is also very convenient. Like you have 15p minus 4r. R is 1 by 2 equal to 3. This would be very simple. You can take any equation. It's your convenient. Can you tell me the fifth equation? What you're saying?
Q plus 30r is equal to 16.
Okay. Yeah, that would be very convenient. So it's Q plus 30 times 1 by 2 equal to 16. The value of R is 1 by 2, isn't it? So it will become 15. So it's going to be Q plus 15 equal to 16. Q is equal to 16 minus 15. So the value of Q is 1. You're getting it? So you can easily find the value of P because P is nothing but Q by 3. So P is equal to 1 by 3. That's it. Yes. So we found the value of P, Q and R. Let me write it here. P is 1 by 3. Q is 1 and R is 1 by 2. Our equation, our given question is in the form of X, Y and Z. So let's rewrite these terms into X, Y, Z. Okay. So what is X? X is 1 by P and Y is 1 by Q and Z is 1 by R. So X is 1 upon 1 by 3, which is 3. And Y is 1 upon 1, which is 1. And Z is 1 upon 2, which is equal to 2. So it's 3, 1 and 2. You are able to follow? So that's our solution. X is 3, Y is 1 and Z is 2. That's it. It's a lengthy question. Okay. It's an easy question only, but it looks like a zombie with the X square roots and all that. It's easy only. Let's do this. So the question is square root of 15x square plus square root of 3 plus square root of 10 into x plus square root of 2 times square root of 5x square plus 2 root 5 plus 1 into x plus 2 and square root of 3x square plus square root of 2 plus 2 root 3 into x plus 2 root 2. So what do we have to do with this algebraic equation? We need to find the square root of this, which means you have to take a square root for the entire equation. In case if you're having an algebraic equation like this, like x square plus y square plus z square equal to 1, if they're asking you to find the square root, you just simply have to put this, isn't it? So that's what we are going to do here. But before applying the square root symbol, we are just going to simplify this. Let's see how can we do it. So here, you do have 3 parts. Okay, let me mark it with a different color. The red one, blue, black one and the green one. So there are 3 parts. Let's do this one by one. Okay, so let's solve the first one, the red one. It's square root of 15x square plus root 3 plus 10 into x plus root 2. I'll write it here. Root 2. Look at the equation carefully. You'll be able to notice a bracket here. What does it mean? This x is common to this root 3 and root 10. So let's take the x inside and do the multiplication. So how can you rewrite this? It will become 15x square, square root of 15x square plus root 3x plus root 10x plus root 2. Can you follow this?
Yeah.
Okay. So now I'm going to rewrite the very first term, which is root 15x square into root 15x square into root 3 into root 5. Root 15 can be expressed as root 3 into root 5. And x square can be written as x into x. Let's shuffle this. Multiplication is commutative. So you can write it as root 3x into root 5x. Can you follow?
Yeah.
Okay. So now I'm going to rewrite this root 15x square as root 3x into root 5x and write the remaining as it is. Write the remaining as it is. Okay. So now, similarly, you have root 10 here. I'm going to express root 10x into root 2 into root 5x. Can we do that? 2 5s are 10. So I'm going to change my root 10x into root 2 into root 5x. Root 2 into root 5x. I'm writing this root 2 as it is. Can you follow?
Can we just take out the common in like
exactly
doing the factorization method?
Yes, that's what we are going to do now. We are just going to take the common terms out, which is why we are splitting these. So now what we can do, here also you do have root 3x and here also you do have root 3x. So you can take one term as common out of it. Yeah. So just take root 3x as common and you will be left with root 5x plus 1 from this. Can you follow? Okay. And from the following, you do have root 2 and root 2 here. So you can take one root 2 as common and you will be left with root 2 5x and plus 1. Can you see a common expression now? Root 5x plus 1, isn't it? So you can take that also as common. So it's going to be root 5x plus 1 and you can combine the root 3x and root 2. So this is going to be our final factors for the simplification. On simplifying the very first expression, we just simplified this one. We're done with the first part. Please note it down.
Yeah, I'm done.
Where is the stylus pen? Okay, here. Okay, let's do the second expression. What is the second one? This one. Is here. So it's root 5x square plus 2 root 5 plus 1 into x plus 2. Similarly, okay, I'll rewrite here. It's root 5x square. Similarly, this x is common to 1 and 2 root 5. So just take it inside and multiply. So you can write this as root 2 5x square plus 2 root 5x plus x plus 2. Next, I'm going to simplify root 5x square as, I'm going to express root 5x square as root 5x into x. Okay, so root 5x into x plus 2 root 5x plus, you have x plus 2, write it as it is. You have root 5x here and here also. Can we take it as common?
Yeah.
It will become x plus 2, isn't it? Write the remaining x plus 2 as it is. So now from this, if you look at it, x plus 2 is common. You can take it out. So x plus 2 into root 5x plus 1. Understood, Manasi?
Yeah.
That's why we are having the expression here. Okay, let's solve the third one. Third one is this. This one. It's root 3x square. It's root 3x square plus root 2 plus 2 root 3 into x plus 2 root 2. Again, this x is common for root 2 and 2 root 3. So it's root 3x square plus root 2x plus 2 root 3x plus 2 root 2. Yeah. Again, you can express root 3x square as root 3x into x. So it's going to be root 3x into x, root 2x, 2 root 3x. Just write the remaining stuff as it is. So look at the first two terms. What can we do?
Maybe take x as common.
Okay, if you take x as common, you'll be left with root 3x plus root 2. From the following term, you can take 2 as common. You take 2 as common, you'll be left with root 3x plus root 2. So now root 3x plus root 2 seems to be common, isn't it? So take that as outside. Root 3x plus root 2 is common. You are left with x and 2. Combine them. That's it. We are done with the third expression also. Is it clear?
Yeah.
Now let's combine all this. All the three equations are in multiplication. So let's multiply all these three factors. Here, the expression 1, 2, 3. All these three equations are in multiplication. So I'm just going to multiply these three answers. Over here they wrote everything. Okay, I'll show you, I'll differentiate it with a color. Like this is the first one. And you have the second one here. And the third one here. In our question, they are asking us to take a square root. They are asking us to find the square root on this algebraic equation. So you just have to draw a square root on this. Understood?
Yeah.
What do you mean by square root? In case if I'm having 2 into 2, I'll take 1, 2 as common out of it, isn't it? And I'll remove the square root symbol. That's what I mean by square, right? Square root of 4 is 2. Square root of 4 can be factorized into 2 into 2, and you can take 1, 2 as common out of it. You're getting it?
Yeah.
Okay. So now you just check whether you have a repeater terms or not. Root 5x plus 1, root 5x plus 1. So you can take 1 root 5x plus 1 as a square root. Root 3x plus 2, root 3x plus 2. So you can take 1 root 3x plus 2 as common. X plus 2, x plus 2. So take 1x plus 2 as the square root of this. Understood, Manasi?
Yeah.
Yeah. That's all about this. I hope it is clear.
Why have we given it as absolute value?
Okay, the question is given as absolute actually. The question is, sorry, I forgot to tell you about this absolute value. The question you'll be able to notice a square root. That is why they just put the absolute symbol at last. Which means even if you're getting the answer in terms of negative, the negative will turn into positive. Nothing much. So just draw a square root at last. I mean square bracket. Yeah. Or draw 2 lines. So the example 3.31, they gave a quadratic equation 2x square minus x minus 1 equal to 0. So they're asking us to solve the equation, which means we need to find the value of x here. So we will solve this equation with help of a completion of the square method. Completing the square or completion of the square. I'll tell you how. We'll use the basic algebraic formula, which is a plus b the whole square or a minus b the whole square. It's based on the symbol. You will understand easily. Okay, let's solve this. So you have 2x square minus x minus 1 equal to 0. So the very first thing is you have to make the coefficient of x square as 1. Okay, so you have 2 here. So you just have to divide the entire equation by 2 in order to achieve the coefficient of x square as 1. It can be any value. It can be in the form of a fraction or a decimal or any integer. You just have to make your coefficient of x square as 1. That's the first step. So if you divide this, it will be like this. 2 and 2 will get cancelled out. We'll be having x square, x minus 2, 1 upon 2 equal to 0. Can you follow this?
Yeah.
So now you can take this constant term along to the right hand side. If you take, this will become x square minus x upon 2. This negative 1 by 2 will become positive 1 by 2 on your right hand side. I think the step 2 is also clear. So here on the third step, we're going to do the completion of the square method. I'll solve it separately. So let's take, you have x square minus x upon 2 here. X square minus x upon 2 is equal to 1 by 2. Take the left hand side alone and solve. X square minus x by 2. I want you to recollect the formula for a minus b the whole square. It is a square plus b square minus 2ab, isn't it? So rearrange this into a square minus 2ab plus b square equal to a minus b the whole square. Can I rewrite the equation as a minus b the whole square minus b square is equal to a square minus 2ab? Can I do that?
Yeah.
Yeah. So now what I'll do, I'll take my question and I'll compare it to it. So if I compare my question with the formula, I found the similar structure. I have a square, x square. Both are in the form of square. You have minus symbol here and minus symbol here. If you have minus symbol over there, you have to choose a minus b the whole square formula. If you're having positive sign, you have to choose a plus b the whole square formula. Keep that in your mind. So compare this to 2ab. Okay. Assume the next thing as 2ab. So I'm going to assume a square minus 2ab as x square minus x upon 2. Already told you this a square and x square are having the similar structure. So a square is equal to x square. From this, if I take square root on both the side, I'll be having the value of x is a. Is it clear?
Yeah.
And I'm going to compare this negative 2ab with negative x by 2. Okay. So negative 2ab is equal to negative x by 2. So cancel the minus and minus. And you know a is x. Okay. So 2b is equal to 1 by 2. So b is equal to 1 by 2 into 1 by 2. I'm taking this 2 to the other side. It will become 1 by 2 into 1 by 2, which is nothing but 1 by 4. Do you understand this?
Okay.
So we found the value of a and b here. Why I am doing this? Just to rewrite this a square minus 2ab into a minus b the whole square and minus b square. I'm just going to write the x square minus x by 2 into this format. So I know the value of a, which is x, and what is b? B is 1 by 4. So it's x minus 1 by 4 the whole square minus b square. What is b square? B square is 1 by 4 the whole square. Do you understand this?
Yeah.
Okay. Please note it down.
Yeah, I'm done.
Okay. So here x square minus x by 2. I'm going to rewrite that as x minus 1 by 4 the whole square minus 1 by 4 the whole square is equal to 1 by 2. Understood?
Yeah.
So now you can take the negative 1 by 4 the whole square to the other side. It will become x minus 1 by 4 the whole square is equal to 1 by 2 plus 1 by 4 the whole square. So now you will be having 1 by 2 plus 1 by 16. X minus 1 by 4 the whole square. So let's take LCM on this. It will become 8 plus 1 upon 16. X minus 1 by 4 the whole square. So it's going to be x minus 1 by 4 the whole square is equal to 9 upon 16. So take square root on both the side. You take square root on both the side. What will happen? This x minus 1 by 4 the whole square will become x minus 1 by 4. And square root of 9 by 16 can be written as 3 upon 4. So x minus 1 by 4 is equal to 3 by 4. And x is equal to 3 by 4. Just take this negative 1 by 4 to the other side. It will become plus 1 by 4. So we'll be having 4 by 4. So x is equal to 1. Understood?
Yeah.
Yeah, that's it. Here, like for while taking square root, what they're doing, when you remove the square root, you'll be having the answer in the form of plus or minus, isn't it? Plus or minus 3 by 4. So if you take it as plus 3 by 4 and solve it, you'll be getting the value of x as 1. In case if you take the 3 by 4 value as minus 3 by 4, you'll be having x equal to minus 3 by 4 plus 1 by 4 minus 2 by 4 and you'll be having minus 1 by 2. Understood?
Yeah.
So that is how the value of x is 1 and negative 1 by 2. Shall I erase it?
Yeah.
I hope it is clear.